Myself, Mukesh Kumar from TERI, presenting theme 3 energy storage. Uh, these are the objective for the TERI urban pilot projects under theme 3 and to design the energy management system control logic with coordinated supply from the utility with use of grid simulator PV and the load. And the objective is to overload management and peak saving of the distribution transformer feeder level by integrating the energy storage and with use of solar PV. And the study of the peak saving energy shifting application of energy storage system using sample switching profile for load emulator and emulated solar PV generation. And the objective also is to battery management system logic development in the MATLAB, hardware in the loop, testing by using the NI Stereo in LabVIEW, and using grid simulator, load emulator, and the battery simulator. And these are the benefits which the stress reduction on the distribution network, uh, increase in the life of the DT while using the battery energy storage, voltage support for distribution network. Distribution network need to be designed to get the peak loading. The charging of EV during off-peak period and the environmental. These are the approach and methodology for urban pilot projects. As in the first phase, we have studied some load research and consumer behavior analysis with different categories. Like we have category A, B, and C. Under category A, there is peak load management. Category B is a society, and under category C, there is TERI University. And the next to identify the possible application for different category of consumer alongside the site selection. And then after designing the appropriate control algorithm for selected application and performing the cost benefit analysis for the same. And after battery energy storage power rating evaluated based on the distribution transformer capacity and the load analysis. And network modeling simulation study to analyze the charge discharge response of energy storage along with the development of the EMS based on the model predictive control and the ANN technique. And after that, we have to identify the secondary application of BSS and validate control logic in the RTDS simulation. These are the category A, B, and C. Under category A, the DT rating is 990 kVA, and the maximum loading we have seen from the data is for 2017 is 65%, and the expected maximum loading in 22 is 89%. Under category B, this is the society apartments having the 120 kilowatt rooftop solar PV generation installed, and along with 320 kVA DG set. The consumer opted for a regular tariff scheme. However, TOD is optional during this, and the power outage in the society is 2 to 3 hours during the months. And there is the common load demand during the power cut in about 200 kilowatt approximate. The TERI SAS is under category C, and the DT rating is 600 kVA. And for pilot location identified is category A, Tamil Nagar. In category A, the power rating of the battery energy storage is 120 kilowatt, 25 kilowatt, 230 kWh. And the final chemistry is LFP under all three categories. And the primary application for category is overload management of distribution transformer. For under category B, the primary application is backup power and demand response. And category C, there is TOD tariff applicable during May to September month, peak hour and off peak hours. And so there is the application for category C is energy time shift. There is identified the secondary application for category is energy arbitrage for the utilities. And under category B, there is secondary application of energy arbitrage and Under the category C, the secondary application identified as the battery utilization of the solar PV generation while using the battery energy storage. These are the battery energy storage sizing and control methodology for category A. We have used the two-stage modular approach for evaluating the battery energy sizing. The 230 kilowatt was identified as appropriate size of battery with expected to load in year 2022. We have developed the basic control logic for the energy storage system and optimizing of the energy storage operation based on the load, weather forecasting, and aiming to extend the service of the life of the DT while calculating with the loss of life of the distribution transformer. These are the simulation results for the category A. Here we can see the distribution transformer loss of life is modeled as per the IEC standard, and the red line circle shows the indicate the high loss of life during the summer months of the distribution transformer loss of life. And the left hand side, the simulation result shows the charging and discharging curve of battery, load power, grid power, and the solar generation is shown. And the cost-based benefit analysis, we have assumed the modular approach. We seen that the 35% increase in the capex value and the benefit to cost ratio is 1.25. This is the control logic under secondary application mode, and the aim is the secondary application is to define for battery utilization of the battery energy storage, because the peak demand is only for 3 to 5 months only for the because in the grid level. This is the battery energy storage control methodology for the benefit assessment of the category B, and the SPD connection 3 into 630 kV DT, and the 3 distribution PV plant have total capacity of 120 kilowatt under category B, and the power cut is around 2 to 3 hours in a month, and there is a separate LT panel for the common load in each block, and the 100 kilowatt approximate common load, which includes the elevator, street lights, corridor lights, and water pump for the society. And there is the other application for demand response is being explored. And there is also the DG having the 320 kV rating, and the DG load is 60%. During the power outage, the 2 hours per month, the DG is operating. For the category B, the battery useful capacity is identified as 120 kilowatt to 40 kilowatt. Maximum loading demand during the outage is 192 kilowatt for the common loads. This is the secondary application flowchart for category B while using the energy. This is the control method for category C, where you use the because there is the TOB tariff applicable under this category in May to September months, and while we charging the battery in the off-peak hours of the tariff, and they discharge it to the peak timing. And under this secondary application of the category C mode, we use the solar PV generation to charge the battery, and while discharging at the during the there is no solar in the system. So these are the benefit assessment for category C, TERI Sassoon University. The identified battery capacity is 200 kWh, and peak price is 9.6 rupees per kilowatt hour, and the off-peak price is 6.4. The battery size is optimized. The graph is shown here. There is the annual saving battery size in rupees per kilowatt hour. And the future task is to testing the charge and discharge performance of the lithium ion pack by utilizing the regenerative test bed and in the battery simulator at the TERI lab. And then the modeling and simulation of hybrid PV battery system in MATLAB for grid connected and off-grid application similar to the category B. And then the development of the prediction-based energy management system for thermal management of DT optimizing the use of battery energy storage system and using the artificial neural network. And after that, we have tested and validation of control logic. We have model in the MATLAB in the real-time platform RTDS at IIT Kanpur. Thanks.